folks, I'm Joe Storer. Long time no see. Genshin, UGC just went live, and, while learning the ropes, I whipped up a chill little racing map. I need Creator Level 3 to unlock text labels, so please hop in, smash that like, and give it a spin. It's a classic racing style. Hold forward to accelerate, steer left or right, and reversing has no effect. The skill provides a temporary boost. Before the race starts, you can't move, but can hold to pre-accelerate. Then dodge obstacles, hit speed boosts, and reach the finish line as quickly as possible to win. However, it's not recommended to play between 8 p.m. and 12 p.m. My recent tests revealed that the frequent timer during peak hours is highly unstable. Even with a 0.3-second interval, it often gets overstock. Sometimes, the server will kick you out directly. Since manual motion controls are quite specific and rely on stable, high-frequency updates, after all, having your car speed change every second would be awkward. It's currently best to play when the server is relatively less busy. Actually, I originally intended to create a standard circular track by programmatically controlling lens rotation through 72 lenses, each set to 5 degrees. However, for unknown reasons, the 2.5D lenses frequently fail to switch properly under certain parameters, so I had to settle for a straight track instead. I hope the developers see this and can fix it. Next, we shall outline the implementation principles of certain features, along with sharing some pitfalls to avoid. One aspect requires a certain degree of skill is implementing programmed free movement control for the camera, along with capturing joystick input presses and releases from devices such as computers and mobile phones. Currently, Genshin UGC does not provide APIs for these functions, necessitating the implementation of special methods. Camera control is rather straightforward. Provide the player with a platform enclosed by 4 collision boxers. By creating and deleting movement controllers, you can achieve directional movement and camera controls. Placing the spawn point and platform underground ensures they remain unaffected by surface obstacles. Should you wish players to control the camera using WASD, it's even simpler. Just simply attach a follow movement controller to the platform, so it tracks the player's position. Next comes capturing press and release events for movement inputs. When you see a player enclosed by a collision box, you might assume that obtaining their velocity and direction would suffice. In practice, this approach fails. This is because the velocity node provided by the UGC represents the actual kinetic velocity. If the player is immobilized within the box or encounters any other situation, such as being cornered, their velocity will register as 0. And monitoring for changes in movement velocity will also prove ineffective. Of course, this clearly posed no challenge to me with over a decade of experience researching Warcraft 3-star cards. We can observe a distinct difference between pressing and releasing. The player's animation. When pressing, the player moves and their arm swings. Naturally, we might conceive of attaching an object with collision detection to the player's arm. By triggering collisions during the intervals of the arm swing, we can capture the distinct actions of pressing and releasing. One particularly important point to note is that after an object is mounted using a motion tracker, load optimization still uses the original position as its reference point, with a radius of approximately 100. This can cause detection failure when the object moves too far away. Therefore, load optimization must be disabled for this trigger source. Additionally, if you're developing a multiplayer game, based on my testing, hiding player character entities causes objects mounted with tracking to stop following their movements. Therefore, avoid using the model hiding feature. Instead, hide characters underground and enable collision ignore, in conjunction with a 2.5D camera. This way, you achieve a camera that can be both freely controlled by the player and programmatically controlled, along with separate motion input capture. You can then forward the captured input to other components via nodes, enabling the separation of camera and control functions. Additionally, a brief preview of 2 other related projects I've been working on in my spare time. One involves making Genshin Impact's UGC programmable in TypeScript. And the other is a Genshin-inspired MOBA RTS, I've handcrafted using Unreal Engine. Finally, would you mind giving my Slime Rampage a play? It'd be a huge help if you could bump up my creator level. Pretty please.